Okay. So, any questions over last week's stuff you guys have? If not, it's fine. Um, so what I'll do is I'll share my screen and then I'll start in on the uh, Blackboard and the things we'll be doing. Okay, so let me know if you can't see my screen. You should be able to see it though, and I'm looking at right now Blackboard page for the class. So for week 2, everything is in lessons, and we've got the same things we had from before. Of the reading assignment is that this is out of chapter 2. Our chapter objectives, all our key terms and everything that's not changed. That's all here still. And we have the PowerPoint if you want to take a look and follow along. I'll be going through this and be doing Flowgorithm as well for hands-on examples of what we're talking about in PowerPoint here. So I'll open this up and then we can take a look at it. And if you want to follow along with Flowgorithm on your own, you can as I go through these things. Or if you want to just watch it and then come back to it later, you can as well. I'll post the recording up and share it later this week, hopefully by either the end of today or tomorrow. Should have it up so you guys can go back through and look and watch this again. So chapter 2's main things are about variables and constants and operations, modularization, which we'll talk about again, and then hierarchies and features of good program design. So the big thing is the data types of variables. We've talked about this already in class, but there are the basic data types. There's 3 real basic ones. There's a numeric, which are numbers. You can use in math. A string, which is anything not used in math, like text or anything like that. And then there's also a Boolean one, and Boolean is true or false. Now in the numeric, that's typically split up into 2 different things for numbers. You have usually called an integer, which is a whole number, and then you also have the real or double or float, which is the decimal number. And so that's usually the way numerics are split up. So typically in programming languages, you'll have 4 data types that you use for variables. And if you remember, let's see, the 4 data types. So if I pull up Flowgorithm here, we'll zoom in a little. In Flowgorithm, to do a variable again, you click on the arrow and then do a declare here for the variables. So declaring again is just like creating a bucket to store information. So once you click on it, then you just double click the symbol there to open up the declare properties window. And in here, you'd specify the variable name of whatever it happens to be. So as an example, we could use myvar as a variable name. And then you have the data types here. So again, we have, for Flowgorithm, we have integers, the 4 data types. The integer is the whole number. The real is a decimal number. So these 2 you can do math on. So multiplication, division, addition, subtraction, all the math type things for numbers. And then string is text or anything that doesn't do math on. And then you have your Boolean value, which is true or false. So these are the 4 data types that you'll typically be dealing with in programming. So if we do an integer, it's the whole number. We click OK, and then it in Flowgorithm declares the variable myvar as an integer. So that's kind of the data types of variables. So there's also a constant, and these typically are only numbers. Or a literal numeric constant. And so that is, as an example in Flowgorithm, when we do an assign. So the assign is the processing one in Flowgorithm. If in here, for our variable, on the left we say myvar, on the right we say an actual number, say like 5. This 5 right here is the literal. This is the actual data, literal constant. And so if you hear somebody say a integer literal or a string literal, they're talking about the actual information, the actual data. It does not change throughout the running of the program. If I put 5 in here, every time I run this program, it will always be 5. Does that make sense? So then this is what they're talking about here, this number 5, when they say a literal numeric constant A literal string constant, same thing, just instead of a number, we'd have a double quotes around the value. So if we do another variable here that we can declare, and we'll double click on this to pull up the declare properties window. And if we call this one, say, my string, and we set this as a string variable instead of a integer, this will be a text one. So this is the variable part. And then for the literal part, we'll do an assign, and we'll assign the value to my string. So in the assign one here, we'll have my string on the right for the variable, and then on the left, where in this, or sorry, on the right in this square, we'll have the string literal. And so string literals are almost always surrounded by double quotes. And so this would be, say we had hello in there with an exclamation. This part here is the string literal that's highlighted. And so that will never change throughout the running of the program. It will always be hello. So that's a string literal or a constant value there. Okay. So that's what they're talking about here with these two values. We've talked already about declaration. That's creating the variable. So you have the data type, which we put in there, then the identifier or the variable's name, and you can, and a lot of programming languages have an initial value in there as well. So as an example here, this declaration of integer myvar has an initial value of 5. And this declaration of a string data type, myString identifier, has an initial value of hello. Okay, so here's a visual of this, and we did this last week where we had the user enter a number, and then we multiplied that number by 2, and then we output what the answer would be. And so they've added from last week the declarations, which we did as well. And here they're declaring the two variables, my number and my answer, as numerics, and then the user inputs my number, and then we multiply that value they input here by 2 and put it into, store it into my answer, and then we output it. Okay, so we talked about these here. Type safety. So what this does is, as an example in here, in Flowgorithm, if I run this right now, this will run and work fine. However, since I said my string was a string, and in here, instead of the word hello, if I put the number 5 in here, so like if I cut this out, put 5 here, it's going to complain when I run this, because it's going to say variables can only be assigned to data that's compatible. So I said that my string was a string, right? And then I tried to declare, or once I declared the string there, I tried to assign that string a number 5. There's no double quotes around it. So this is not legal. Same thing with the integer myvar here. If I tried to assign a decimal number, or if I tried to assign a double quotes around it with a string, it'll tell me this is not legal. And so this is called strongly typed, meaning that once I set up the variable as a certain data type, so I said my string is string, I can only put strings in the variable my string. So this variable here has to have as an input something with double quotes around it. Okay, so if I wanted this to be 5, I could still put a 5 in there. I would just have to put double quotes around it. Now when I do that though, I can't do math on that because it's a string. If I try to divide that by 2 or multiply it by 2, I'm going to get something weird or an error. It won't do math on strings. So anything with a double quotes around it is a string literal that cannot have math applied to it. So we've talked about the identifiers. So some rules around identifiers. Typical languages have the identifiers of variable names. They can't be keywords. So you can't make them, so every language has a keyword, something that is saved for the language to use, like input or output or print, things like that. You can't use those special words as variable names because the programming language or the computer will think you're talking about that special thing. When you do this, variables, they have to be one word, no spaces in them. Otherwise, the computer will think they're two different variables. You have to start the variable with a letter. You can't start with a number, typically. You also usually can't start with certain special characters like $signs and things like that. It just depends on the language. Some languages will allow you to use certain special characters. And then For naming conventions, you should name them with something appropriate. So like if you do all your variables as A, B, C, D, it's not going to make much sense when you're getting in there going A times B times C. What does all of that mean? Whereas if you're doing like we did with our hourly wage, you name the variable hours worked, regular pay, and then overtime hours worked. That makes sense. So then when you're doing the multiplication of regular hours times hours worked, that actually makes sense to what you're doing. You don't have to go back and look at the variable name A and B and try to figure out what they are. It tells you in the variable name what they are. So being nice to other programmers and yourself as well when you come back later to something you did years ago, make sure the names of the variables mean something to what they're holding. So like if it's a person's age you're holding, name the variable age, something along those lines. So again, here's the declarations for my number and my answer, and they kind of make sense for what they're being used for, right? So it's storing the number, my number, and then the my answer is storing the answer. Okay, so for naming conventions, so there's some set rules we went through that you have to follow. These are things you can follow or ways you can name or do names for variables, different types of ways to do it. So camel casing is set like this because if you put the word camel and casing together and capitalize this C, it looks like two humps of a camel. That's why it's named that. But basically, the first word of the variable is all lowercase, and then the second word, the first letter, is uppercase. And you can have as many words as you want. If you had a third word, the first letter would be uppercase. So in camel casing, the first word is the only one that's all lowercase. Every word following the first letter is uppercase. Pascal casing has the same thing, except that the first word's first letter is also uppercase. Hungarian notation will put in the variable's data type as well. So if it's a numeric and it's named hourly wage, you put the numeric in there. If it's a string, you'd put string or str at the front of it, something like that. So that's Hungarian. Snake casing has a underscore in between them and all lowercase. Mixed case with underscores does the uppercase letters and then an underscore. And kebab has a dash or a minus in between them, separated, and they're usually all lowercase, like a stick kebab through vegetables. Okay, so we've talked about an assignment statement or a processing statement where the value on the right is calculated. So we take whatever's in my number times 2, and then we set that value to my answer. So my answer will now store whatever the calculation result is here. Assignment operator is this equal sign right here. You use one equal sign to assign the value on the right to the variable on the left. This is what's called a binary operator because you have two operands or two things, one on each side of the operator. This is also known as right to left associativity, which just means you start on the right, do everything on the right of this operator, and when you're done, then you move to the left and put it into that value. So the result of the left one here is called the L value for that assignment statement. Okay, so initializing is basically just saying I'm putting a value initially in the variable. So here, the numeric your salary is initialized to 14.55. The variable your name is initialized to Janita or Juanita or whatever. So if you don't initialize this, you don't put an initial value in the variable, when you declare the variable, like numeric your salary, and we didn't have the equal on the right here, then numeric your salary would be holding garbage, meaning that there's nothing in it or we don't know what the value is. So in all programming languages, you have to declare the variable here. You have to state the variable name at a minimum, and then the data type before you can use it or put something in it. So as an example in Flowgorithm here, if I tried to take this my string hello here and cut that and put that up here above, paste it in here, above where I declared my string, it's going to have an issue because what I'm saying is I want to put hello in this variable my string, this bucket my string. I haven't created that bucket yet. The my string bucket and my string variable doesn't exist at this point. So if I run this, it's going to say there's a problem. I can't read the data before it's declared. So the variable myString was not declared yet. So this declaration here, this order matters on this. This declaration here has to happen before you put a value in it. So we need to move this down below that declaration somewhere so that the value, the variable will exist, or the bucket will exist, so that we can actually put something into it. So that's what the declaration is before initialization, or before setting it. So a named constant is very similar to a variable. The thing with a named constant is that you assign the value once, and then it does not change throughout the program's execution. So as an example here, the tax amount here would be set to whatever the price variable is times the sales tax amount. And typically, constants that are named are all caps, and this sales tax amount would not change throughout the running of the program. So every time you run this program, it will always be the same value. And you would typically set this value at the beginning of the program, initialize it at the beginning. So you do this instead of doing a literal constant here of a number. So what will happen is this sales tax amount would be at the very top, and you would set that to 0.06, so sales tax amount would be 0.06. So the reason you want to do this instead of a 0.06 is, say for some strange reason, the tax amount actually increased or changed, and so now instead of 7%, 6%, it's now 7 or 8%. If you have this number here of the sales tax amount, that could be in your program, say like 50 times. If that number changes to 7% or 8%, then you have to go in and change it in 50 different places to the right number. And you could, in that 50 different times of changing it, you could miss one, you could mistype it, you could do a lot of errors in that amount of time. Whereas if you use a constant here with one spot that it's assigned, then if it changes to 7 or 8%, you change that at that one spot, and then where you've used it 50 times of here, you don't have to change it, and it will work. And so that saves you in maintenance later on, and in changes. It saves a ton of work for you, and it saves a lot of errors that could happen. So if you have a number that's not going to change throughout the running of the program, like sales tax, I typically would recommend doing a constant value in there to hold that value so that you don't have to change it later on in lots of different places. So programming code all has the typical arithmetic or math operators, plus, minus, asterisk is for multiplication, slash for division. Those are the same as all the math ones. They work the same as math. There's a precedence order for these. There's also a fifth one that's called modulus, which gives you a remainder out of a division rather than the division, it's the quotient of the division itself. And we'll talk more about that too. But the math operators in programming work exactly like they do in your math class. There's an order of operations of which one you do first, and math are left to right associatively, meaning you start on the left and work your way to the right. So the precedence here is reversed order here. So division and multiplication are the highest ones, meaning that you start on the left of the expression and you do all the division and multiplication first. Then you go back through and start on the left and do the subtraction and addition next. And then once you're all done with that, then you do the assignment of whatever the result is into the variable on the left. So as an example, if in my var here, we were going to say do some multiplication or something and division and all that, if we did 5 times 3 plus 2 divided by 5, divided by 5, this works just like math. The computer programming language will take 5 times 3 first, then 2 divided by 5 next, then the result of 5 times 3, 15, and the result of 2 divided by 5, some decimal number, add those two together and then get the result and put that into my var. So the precedence here works the same as you would in math. Okay, the remainder operator modulus. So their example here is if you're going to take 24 divided by 10 what you get is 10 goes into 24 once with a remainder of 4. So 24 mod 10 would give you the value of 4, which is the remainder. So that's modulus. That's used a lot for truncating or cutting off things as you're going through different, usually different arrays. So the module, or also known as subroutine, procedure, functions, methods, all 4 of these names, or 5 of these names, mean the exact same thing. Basically, you can think of the program when you're walking through the main part of it in Flowgorithm, like we have here. As you walk through this, you can think of this as a conveyor belt in like a factory. We're walking through and we're doing each piece of the assembly at a time. And so what we're doing is we're adding things in there. So we got some chat here. Sorry. Exponents. Questions. Sorry. Yes, you can use exponents. It depends on the language. And yeah, you can unmute if you want to ask some questions too, and I'll check the chat. But yeah, you can use exponents in here. In Flowgorithm, the exponents, I don't remember, I'd have to look it up. But in most languages, exponents are either a caret, so that would be a caret like above the 6, like this, or I know in Python it's 2 asterisks for an exponent. Or also a lot of times they'll put it into a function or module. So what you would do is if you wanted to take 5 to the power of 2, you would say POW for the power 1, and then you do the 5, which is the base, and then a comma 2, which is to the power. So this will be the same thing as taking 5 squared or 5 to the 2nd power. And so a lot of languages will do powers or exponents this way rather than having an operator. And so this fits right in with what we're talking about here. This POW is a module. And so what happens is like I said with the conveyor belt example, it would be going through doing each one of these in line in the conveyor belt. And then when it got to this and it said POW, it would pop out of this conveyor belt like a paint room where you take the car off the paint, off the assembly line and go to a paint room to paint it. This does the same thing. It would take the values 5 and 2 and leave this assembly line version and go to another one that would be the power module or function. And then it would walk through that and do what it needs to. And when it gets done, it would bring a result back from there. So it brings the car painted from the paint room back to the assembly line here where we left. So back to here with the result, stores that result into my var, and then we move on. So a function or a module is kind of like a break from the processing to go do something specialized. And then when you get done doing the specialized thing, it comes back to where the break happened at. So in Flowgorithm, to do functions or modules or something like that, you just click up here to see the different functions that are available in the drop down. But these little circle ones here next to the drop down for functions is the function manager. So you open that and that opens up a new function manager window, and then you can just add functions and go from there. We will be going through this a little more later, but for now you can see how to get to functions. So when you add a function and you click done, it'll open the new function you created and replace the main, and then you can fiddle with it from there. Okay, so functional decomposition of modules is basically just making sure that every piece in the module does one thing. So the paint room only does painting. It doesn't add windows. You don't add other parts to it. You just paint the car in the paint room. That's functional decomposition. So you just do one thing in the function or the module. So abstraction is the idea of well, like in the paint room, right? The abstraction would be I'm concentrating on painting it. This is the important property I need right now. I'm ignoring whether or not the engine is in there or the windows or how they look. Right now, I'm just concentrating on painting. And so that's abstracting that piece out of the whole. It's also known as selective ignorance. I also would term it as divide and conquer. So what you're doing is you're dividing up the work into pieces, and you're conquering each little piece. So modules provide a way to allow the abstraction. Modules also help in team programming. So basically, one person can work on a module or a function and not have another programmer stepping on his toes, and that programmer could be working on a different module and function. And so that allows for different people to be working on the same program at the same time. This also allows for reusability and reliability, because once you create a module in the program, you've tested it and made sure that it worked in the original one, you can move or take that module to a new program and use it again, knowing that it works because it was tested in the original one. And so modules really work well for reusability and reliability. Again, the main program, or the basic steps, the mainline logic, that is one function. That's the main function. There's also other modules that you can add into it. So when you create a module, you have what's called the module header, which is like a variable identifier. It's the name of the module. The module body then has all of the statements or instructions that the module does. And then the module return statement at the end is what do you come back to the main line logic with from that module. So when you name a module, you follow the same conventions and rules as you do a variable, and the only difference is that module names are followed by a set of parentheses. Okay. Blackboard only has one assignment on Module 2. There's not 2 assignments for the Blackboard Module 2 this week. And typically, we will have 1 assignment a week, usually. Okay, cool. All right. So we've been talking about flowcharts and modularizing it. You can draw each module separately with its own sentinel. So we'll go ahead and modularize this one. So we have here, if you want to follow along the flowchart, go ahead and open it up. We'll do this one, and we'll modularize this guy, where we will take the output here and we will put that into a module. Okay, and so when we get done, it'll look like this instead. So let's start first with this. We're going to have a name and a balance that will variables to input, and we'll display the labels, and then we'll add to the label a customer name and a balance for that label. So the first thing we'll need is, so I'm going to use this flowchart. I'm just going to redo this here. What I'm going to do is I'm going to delete that variable declaration, and I'm going to delete these assigns, and we'll start with here this string declaration. Now I'm going to pull this out here and change the declarations here for the variables to a name and to a I think it was a total that we had for there, a balance, sorry. So it'll be a name and a balance that we will do. And let's do these separate. Let's do the name as a string, and we'll do the balance as a real number. Okay, so we'll declare the string name, and we'll declare the balance here as a real number in case we want to do some decimal math to it. So in here, we're going to ask the user to input the name. So the first thing we'll do is we'll do our output here, and we'll put in the output a string literal, that means double quotes, asking the user to enter the name. Okay, and then we'll do our inputs into the name variable. So again, this input here, this will take whatever the user types on the keyboard and store that into the variable name. So the string variable name will, after this symbol, store what the user has typed on the keyboard. Then after this, we'll do another output to ask for the user to enter a balance. And so we'll do a string literal of enter the balance. click OK. And then we'll do an input to the balance variable. So in here, this will have now the balance variable and the input, and what that will do is whatever the user types on the keyboard will now be stored in the variable balance. So the next thing we need to do is we will do, so instead of just doing it like this where we have all the outputs, I'm going to go ahead and do a module first, and then we'll put the, or function, we'll put the outputs, the display address info outputs into into that module. Okay, so it'll look like that. So what we're going to do is we're going to do a new module. So up here on the top tool ribbon, there's these little pills. This is the function manager. Click on that, and then we'll add a module to this. And the module will be named display info. So when you click add, it opens up another window, which is the function properties window. And so in the function properties here, we'll do the function name of display info. And there are no parameters, so don't worry about that. Return type doesn't have anything on it either, so don't worry about any of that yet. So once you have the name in there, all you have to do is click OK, and that will create the display info module. And then when we click done, this will automatically open the display info module or function. Now you notice the main one went away. Now the main is still there, it's not disappeared or deleted. You can get to it just by clicking, you notice how this changed to display info? If you click on that drop down, you can click on main there and you can go back to what we had before, okay? But if you want to go back to the display info, just click the drop down and you can get back to display info. So in the display info here, we're going to do our output here of these values here. So the values that we're going to output is ABC Manufacturing is the first one. So we'll do that here, and we'll output our ABC Manufacturing string literal. Again, string literals are just double quotes. So ABC Manufacturing. Okay. And then the next thing we're going to output is the 47 Park Lane. So I'll put here and string literal here of 47 Park Lane. Next one will be Omro, Wisconsin 54963. So I'll put here Omro, WI 64953. I think close enough. And then again, don't forget to put the double quotes around these outputs so that it will display exactly what you have between the double quotes on the screen. Okay, so this is our function. So what will happen is, as we're going through main, we're going to call display info, and main will then, the computation or processing will jump to display info, and then it'll go through and do these values on there. So we need to call this method. So this is a lot like playing catch. So main here has the ball, it's doing things with whatever ball it's using, and then we need to throw the ball or throw the processing to display info. So we need to say, hey display info, I want you to catch, I want you to take over. And so down here at the bottom after our input balance, right here we're going to do a call. So under the control one, there's this purple one with the two bars on either side of it, left and right, that's the call. We'll click on that, and then we'll double click on the call, and this works very much like the input or output one, except we will call a function. And the function that we created was display info. So now this display info here needs to be spelled exactly like the name that you used or that you named the function that we just created. Now the other thing we need to do is with a function, you need to make sure you put parentheses at the end of it. This allows, or this tells the computer that it's a function and needs to go to the function. So all functions or methods, modules, they all have parentheses at the end of them. So we click OK. Now what will happen is the program will be going through and it'll do the create the name, create the balance. It'll display, enter the name. We'll then put the name, all of that. Then when we get done inputting the balance, what will happen is it'll hit this display info call, and it'll jump from here to display info. And so it'll go here and it will output these three values. And when it gets done with that and hits the end, since there's no return value, we're just going to return back with nothing back to main, and then we'll be returning back to here, and then we'll come down here and we'll end, and that'll be the end of our program. Okay, so if you run this right now, you should see in the console, the first thing it says is enter the name, and it's waiting for us to input a name. So if we say Joe, and we hit enter, and then we hit the balance, that's the next one. It's looking for us to enter a balance number. So if we say Joe has 150.50 for the balance, and we hit enter, the next thing it'll do is it'll jump the display info and display those three values, and then we come back to main and end. So that's the program. Okay, so they have us doing one other thing where they display the customer name and the total, so we can do that as well here. So we could do an output here, and we can display the customer's name. So we'll say in double quotes customer, and then we'll do say a colon and a space and double quotes, and then again Flowgorithm, to add a variable value to a string literal, you put the and sign, which is above the 7 on the keyboard, Shift 7, and then you just put the variable name identifier there that you want to have displayed. And so what will happen is it'll take customer and the colon there and then a space, and then it'll tack on whatever value is in the variable name to the end of this and display that. So we'll display the customer, and then we'll display their balance. So we're going to do output here. Double click on that for the output properties, and then we'll say here in double quotes string literal balance and a colon and a space, double quotes, and then again our and sign, ampersand, and then the variable that we want to display next to the string we have there. Okay, so now if you run this, you'll see it asks for the name, so we put Joe in there. It asks for the balance, say again 150.50. Then it'll display the three values in the display info, because we jump from here to the display info method, and we come back, and then we do the outputs down here under that for Joe and balance. Okay, so that's how a function works. Okay. So scope. Scope is basically the idea that, so it's not mouthwash, it's the idea that variables and constants live in a certain area. They're available or accessible in a certain area, so they have a scope of where they exist. And so as an example here, if I tried to access the name variable in my display info module, it won't be able to, because name was declared here in the main one. And so the name variable only lives or exists within main here. If I try to access this variable name in another function, it won't be able to access it because name doesn't exist outside of that. That's called local scope. If I create a variable inside display info, so if I go over here to display info and I declared a variable in here, that variable or constant would only exist or live within display info here. I'd only have access to it within here. I could not use that variable in main because the local scope, it dies, that variable would die once I leave display info. Okay, so you can't use a variable in two different functions. You can only use the variable in one function at a time. Now you can pass things back and forth, pass values back and forth, but not variable names or actual variables. Okay, so this makes it to where the modules are self-contained and can be portable, meaning that I could use my display address, display info function here in any function, in any program. I just have to copy the display info function over to that program, and then I can call it and use it. And I wouldn't have to worry about making sure that variables are there or anything. It all works on its own. It's self-contained. and that makes it easy to pull things in. There's also called from local, that's what we were just talking about. There's also a global variable and constant, which are declared at the program level and are visible to all modules and functions. Now, most programmers try to avoid global variables because they tend to cause a lot of errors. So what happens is a global variable will have a value assigned to it in one modular function, and then another modular function will change that, and then another modular function will try to read it, and in the meantime it's been changed from what it was, and so then you got to go through all the functions and modules and figure out where it got changed, why it got changed, and try to figure out why there's a problem with the variable. So most programmers try to avoid global variables. However, global constants, since they don't change throughout the program, are used quite a bit. So like the example of the sales tax, that could be a global constant that would be used by all functions or modules because the sales tax shouldn't change in the running of the program. And so it'll be the same throughout the program. So as an example here, they have the declarations that they created of these 3 string variables that they then output. And these 3 string variables only live or exist in display address info. If I tried to access line 1 or 2 or 3 in here in the main, I would get an error saying that that hadn't been declared because it's declared over here and only exists or lives there. That's a local one. Okay, most programs are divided into 3 things, 3 areas of 3 different type of structures. So you've got the housekeeping tasks, which set up everything and get ready for the program, open files, ask the user for input, things like that. The detail loop tasks do most of the work, and then the end of job tasks, it would be putting out a by message or closing a file if you've opened it to read it. Those are kind of the 3 things of the way most programs break down. And so they look like this. And we haven't talked much about loops yet, but we will. But what you have is you have your housekeeping module or function that you would jump to do different things. And then you would have the loop here, and this would keep going through this and doing the detail loop modular function as long as you have not hit the end of a file that you're looking at. Once you have hit the end of the file, then you would go to the end of job. We'll talk more about loops and how they work next week, I think, is selections. We'll get into loops eventually here. But we'll talk more about them. So they basically just loop until something is true, typically, is how loops work. So this is a payroll report that we'll look at here. And you can see this is how it's going to kind of go through. So you'll have your housekeeping module function that's over here that would just output the report heading, the column heading, and ask the user to input a name. And so that would, on our display here, would output this payroll report and output these headings here of name, gross, deductions, and net, and then would ask the user to enter a name. So the user would enter the Andrews name. And then once they input a name, we check to see if they input an actual name or if they input the name that they gave us was not equal to our quit variable or a quit constant, which here in this case is 3 x's. So as long as the user does not put in 3 x's, we will continue to loop. And so when we get in here, we'll jump to this detail loop, and the detail loop here will jump out here, and it will then ask the user to input a gross value, and then it'll do a calculation here of deducting the gross times the rate, and then it'll do the net of the gross minus the deduction, and then it outputs those and then asks the user to enter another name. So this detail loop here does, in this report, it asks the user to enter the gross, and then it does the calculation for the deductions and the net for them and displays them. So it does each row here is that detail loop on these and on the information side here of numbers. Okay, so that's the detail loop. Then it adds the name, which would start the next row here for Brown. Okay, so then when you're done with all that, the person's hit 3 x's. Then you would go to the end of job, which would then output this end line here, which they created as a constant global, which is this end of report, which shows up down here. Cool. So that's kind of a typical loop. So a hierarchy chart is just a planning tool that you would use to document things. And basically it's just, here are the modules or the functions that are going to be in the program. And then these are the ones that call each other. So you'd start with your main program, and the main program calls the housekeeping, calls the detail loop, calls the end of job. So that's the hierarchy there. A more complex one would be here, where you have the main programming calls these three functions, and then the housekeeping function calls the get order function. So this is a billing program. And then the detail loop function calls these two functions, get order and process order. Process order calls these three functions, and the compute bill function calls the compute tax function. Now, in a function hierarchy or a module hierarchy like this, when you have a little colored triangle on the corner, that just means that there's another call of the same function. So this get order function is the same function as that get order function. So you don't have to type the get order function twice. You type it once, but you can call it twice. And so that just signifies that this is called somewhere else as well. Okay, so that's the hierarchy there, chart. Comments and programs, these are things that are ignored by the compiler or interpreter. When the compiler or interpreter goes through and turns the code into zeros and ones, it ignores the comments. Comments are used for programmers, for us, as notes to each other, notes to ourselves as well. So good programming, good design. Make sure your identifiers are carefully chosen, your clear statements within the programs and modules. Your prompts and echo inputs are clear so that users know what you're expecting. And so you just, good habits that you would develop as you program. So comments, they're typically explanations of the statements. What's the statement doing? Kind of a breakdown of this is in English what the statement is going to do. They're not part of the logic, and they serve as mostly internal documentation, like I said, for us programmers to communicate with each other, and also to remember what something is supposed to be doing when we come back to it years after we've typed it or programmed it. Okay, so the syntax is different among programming languages for comments. Some programming languages use 2 forward slashes. Some use the hash #, just depends on the language. So in the flowchart, there's an annotation symbol, which would be like a comment, only it's within the flowchart. And that in Flowgorithm, you can put those in. They're just kind of, usually it's a dotted line with a little bubble kind of thing that would have the comment in there. So here's the / comments. The program would declare a numeric variable called sqfeat first, and then it would ignore everything after these 2 /, and this would be a note for the programmers. Here of sqfeat is an estimate provided by the seller of the property. And the same thing here. It would create these variables, but it would ignore everything after the / as comments. So they wouldn't be as part of the logic. It's just notes for us programmers to keep track of things. So here's an annotation in flowchart that are notes for us. So here's an example. The rate is expected to increase on January 1st as a note. That'll probably have to maintain or change that when it comes January 1st. And then the program here assumes they are all making the same standard hourly rate, that there aren't any differences. We've talked already about identifiers, that they should be self-documenting, basically, meaningful names that you want to have as a variable name, something that makes sense to what the variable is holding. You want to try to avoid digits if you can. Digits are okay in a name, but again, the variables typically have to start with a letter, not a number. So if you have a digit in, just make sure it's after the number. Sorry about that. So pronounceable names should be used rather than gibberish. Don't just randomly type things. Try to make sure the variables make sense. And abbreviations, make sure that they make sense to most people as well. Some other things you can separate with underscores, we talked about that. A data dictionary is basically a way to keep track of a list of all the variables. So it's just, if you have like thousands of variables in a program, you could have a data dictionary that would keep track of all the variables in the in a program. And then you would share that with people and they would be able to see what the variables are. So one way to use variables is to have temporary variables to clarify long statements. So I did this with our program that we did for week 1, the assignment where we did the hours and the rates and everything. I broke that up into 4, I believe, statements, and those are using temporary variables that we used to do the calculation. So you don't want to do, you can do line breaks, meaning you can put the program on different lines, but try to avoid doing weird ones. So a temporary variable or work variable is what's used to break up something that could be confusing. So as an example here, the sales commission calculation here is an all in one line where you're taking the square feet times the price per foot plus the lot premium times the commission rate. So that can be a little confusing to try to look at or read through. But if you use multiple statements to compute the commission here, sorry, it'll go to voicemail here soon. So if you want to break this up, what you can do is you can use a base property price work variable and a total sales price work variable that were temporary, just used for the calculation. So we take the square feet times the price per foot calculation here out of the whole line, and then we put it into its own line where we store that into the base property price. And then we take that base property price, which is the square feet times price per foot, and we add that to the lot premium. So that's this plus here, the lot premium there. And we take that value and we put that value into the work variable, total sales price. So the total sales price basically represents everything that's in these parentheses here. So then we take that total sales price times the commission rate, and then that goes into our sales commission variable that we display or do whatever we want to with. So I did this with the hourly wage initially program when I put up on the board the different ones. You could have done the hourly wage calculation on one line if you wanted to, but I broke it up like this so it made more sense and was a little more readable for everybody in the class. We talk about prompts. We've done that multiple times. Just make sure that the user knows what you're expecting them to input. You can echo the input to make sure the user knows what you got back out of them. So as an example here, this input name and balance here with the declaration, there's no prompt. So the user doesn't know what you're looking for, what values you're looking for. It's better to put in a prompt of please enter the customer name, then have the input for the name, then enter the balance, and then you can enter the balance there. That way the user has an idea of what you're looking for. Again, this is, notice the space here. When we do the output, please enter balance due for, and then we put the name there. In Flowgorithm, instead of a comma, we would put an ampersand. But you put the space there so that the name and the for won't be on top of each other, that there will be a space between them. So we've done that multiple times. Okay, so these are kind of some tips for good habits in programming. You do these will help you to not be partway through programming something and realize you did it wrong and have to go back and change everything. These habits will help you be better prepared to actually program and just sit through and do the programming. It'll make the programming actually go faster, even though it feels like all the planning and the desk checking and the code and pseudocode and flowcharts take up time. It's actually less time to do that beforehand than to get halfway through a 5,000 or million line long program and then have to change everything because it's not working like you want or it's not as efficient as you want. So it's more work to go back and change things than it is to plan it out first and then go through and program. So cool. That's the week's lecture. We will not be having a class time on Wednesday. We won't be having set class times either throughout the rest of the quarter. What will happen is I will record lectures. I've recorded this one. I'll put it up on Blackboard, but I will record the lectures for every week. I'll put them up on Blackboard as videos, and you can, at your leisure, whenever you want, walk through those. You can play, pause, go back, whatever you need to with it. But those will be available for you. They'll go through. Each week we'll have a lecture video with on-screen walkthroughs and examples of me sharing my screen. Some will be more hands-on with Flowgrithm than this one was with slides, but it'll be a combination of those. So those will be available at the beginning of the week, and they'll go through all of this stuff. I will be available during my office hours. Good question. I'll be available on Zoom during my office hours, noon to 2. I will also be available. I'll try to make myself available during class time as well. So I'll be pretty much available Monday and Wednesday for you guys, 10 a.m. to 2 p.m. You just shoot me an email and we can connect on Zoom. It'll be the same link for the meeting room, and I'll walk through and answer any questions you have. And I'll be available Tuesday and Thursday, noon to 2 for office hours as well. Just shoot me an email and we'll set up an actual time to meet on Zoom, and you can get on and go through there. Also, there was a survey that was added to Blackboard. I believe if you could, let me check to make sure it's in there. If you could go in and do that survey, that will help us out. It's right here, this info and lessons, info technology survey. Fill that out, and this will help us to know if you have any issues or if there's something access to tech that you have an issue with. You can answer that in there. And we will accommodate you. I am not sure when they'll allow everybody, or when they'll say campus is open back up for students. Right now, as far as I know, the rest of spring quarter is going to be done this way, and classes will not be meeting on campus for the spring quarter. What I know for now is that summer quarter, they'll start back up with, for now anyway, they'll start back up with normal classes on campus and students coming in starting in the summer quarter. If I hear different, or I hear different updates, they should be outputting or displaying or emailing out announcements on that as the quarter goes. But as I hear and as things develop, I will put announcements and send out emails of what to expect for the class. So for now, class will be ran through Zoom. I will be available again during class times on Zoom and during office hours on Zoom. And so just shoot me an email, and I will yeah, I'll try to be available as much as I can through Zoom. So let's see. So this week for Module 2, real quick, the assignment, we have one assignment in Module 2 this week. And that's this Dropbox right here. We will be doing Fahrenheit and Celsius conversion. So what'll happen is, let's make that a little smaller, sorry. What'll happen is we'll have modules to develop that you're going to convert temperatures in. So the user will have the ability to convert Fahrenheit to Celsius. So you don't have to do Celsius to Fahrenheit, no decisions will be made or anything. It's just the user will give you a Fahrenheit temperature, and you'll use this calculation right here to translate or convert that Fahrenheit into a Celsius temperature. So you're going to have 3 modules in this. One is going to ask for the input from the user, one's going to calculate the Celsius, and then one's going to do the output. So what I'll do is later on, either today or tomorrow, I'll record an example that works through that idea. So there's a couple of examples on here that are Flowgrithm examples, and what I'll do is I'll walk through these examples in Zoom, record it, and put it up, and so you can have a walkthrough of each example on Flowgrithm of how to do it, and then the example itself will be there as well. So you can take a look at those. These examples in here should show you how to do the different modules for that idea. Now, it won't be the actual Flowgrithm module or the Flowgrithm code for the conversion, but it will have all the examples you need, hopefully, to accomplish this this calculation or this program. So I'll be going through those later this week and put those videos up on here for each one of these Flowgrithm examples. Okay. So I think that's it for today. This is due in 2 weeks on the 20, let's see what the date is here. There we go. The 29th of March, Sunday at midnight. So you have 2 weeks to do this assignment. Cool. All right. So if you have questions, you can email me. I will be happy to email back any answers for any questions you have or that have come up. And again, I'll put up some videos later on this week that'll go through these examples. And we will be doing what's asynchronous. Basically, I'll record the lecture and put it up on Blackboard. You will not have to be online at a certain time. You can watch that whenever you want. The assignments will be up every week, and they will be due in 2 weeks, just like we've been doing going forward. It'll be the same that way. So the assignments turn in and timelines for assignments will be the same. Okay. So be safe. Wash your hands a lot. Make sure everything is good for you guys. If you have questions, go ahead and do in there. Yeah, I will let you know when everybody is, when I find out on campus times, I'll let everybody know, and I'll send out an email an announcement that you can come back to campus. I know it's much better to be in class and to have the visual, but so yeah, if when I find out when people can come, when students can come back, when we can be back in the classroom, I'll let you know if it changes. Right now, from what I hear and understand, it'll be the spring quarter. And yeah, I will announce the times. If I'm going to be, I'll have Zoom times and I'll announce those. I'll have Open Lab Zoom times. I'll announce those times as well when I'll be available on Zoom for anybody who wants to just drop in and ask questions as well. So it'll be probably my office hours, like half an hour or whatever, noon to 12:30. If people need more time, I'll be on there longer, but I'll have probably during my office hours, noon to 12:30, Monday through Thursday. That'll be a drop-in time. You can just pop in, and the Zoom will be up, and I'll be available. Okay. And yeah, I'll announce times when if things change, and if they allow students back on campus, I'll send out an email and let everybody know, and we'll get back in the classroom. So thanks for being flexible. I'm really sorry about all this. It does stink. But yeah, stay healthy, wash your hands a lot, and don't kiss strangers. So, all right, thanks, guys. Have a good day, a good week, and I'll start putting things up. If you have questions throughout the week, shoot me an email. We can set up a time during office hours or whenever to get on Zoom. Okay. All right. Thanks a ton, guys. Have a good week.